the big one. Okay, I'm very happy to be here for the first time for DSS. Last year at DSS, Anton, one of our engineers, was there to then present what is now known as read-only reentrancy. And I'm using this opportunity to present something new we have been working on also here for the first time to address more a practical problem. And that is like to validate deployments. So just very quickly about me, I'm CTO at Chain Security. Have been in the space for some time, right? But the authors of what I'm presenting here, especially Hubert, has been in the space for a lot longer. The only time you'll hear the quick chain security thing, so we are auditors, right? We work with all the big projects and have been doing this for quite some time so far. So now to the interesting part. What challenges do we face with deployment validation? What challenges do we face if deployments go wrong? So simple things like you can incorrectly configure your deployment, right? You can have wrong code deployed, something you didn't intend, or perhaps like something you didn't have audited. You can even think of malicious deployers pretending to deploy one thing, but really deploying something else, right? And then on Etherscan, you upload a code which actually doesn't reflect the reality. We can have incomplete or broken deployments, right? Deployments can go over multiple steps. You need to make sure that in the end the system is consistent, but you are deploying in a system like on Ethereum, which is public. Everyone can interfere in between. And in some cases, you might do an upgrade, right? And in this case, you did have previous state. And now, with the new code, the previous state might interfere in ways which you didn't intend it. Now, to those of you where you think, wait, okay, that all sounds a little bit theoretical, I don't know how many those are, but there are many examples, actually, of how this really did go wrong. Now, this is where the presentation doesn't go slide by slide, so you can't see all the tweets. Sorry for that. So I'll just have some cases here. Like the most, like perhaps one of the famous ones, Tornado Cash governance takeover, right? So it was a case where someone deployed an upgrade and wasn't perhaps checked carefully enough that there was a self-destruct inside of that code, and that allowed the person to, like, because it was deployed with create2, right, to redeploy. Other cases, like of systems where actually the security on the code might be fine, but it's secured by some multisig, which is actually not a multisig at all, right? We had several very big hacks, which happened to be like that. We had the iEarn, I don't know if I pronounce it correctly, case, like the predecessor to Yearn, which had a wrong USD token configured, right, and got exploited this way, and so on. So I can go on, and for all of these cases, there have actually been exploits. The thing is, like, this is not covered by auditors so far, right? We as auditors, we do focus on the code. We do expand from there, and this is a natural expansion. So what if you could easily validate, just for starters, like which address contains audited code, right? You can go on Etherscan, but you don't know, has this code been audited? It's very hard to figure out, actually. You have a Git repo, right? Where is that code? Is that the code which is live? Am I looking at a newer code which has been updated, push domain, whatever, right? Very hard to figure out. As an auditor, you do have some implicit idea of like a trust model, but is it still valid? Is the system still behaving like that? How can I detect suspicious admin activity? How can I warn for the Tornado Cash case of self-destruct and create2? Can I make all of that not like a lot easier to validate? And in the end, a nice bonus, if you know a system is insecure and you want to prevent people from using it, just to warn them, like, be careful here, right? Can't you somehow do that? So there are some solutions for that, but that's a nice side effect of what I'm going to show here. So, welcome to deployment validation. We propose something we call deployment validation files. So they are very simple files. They describe a correct deployment. They just state this is what it should be. There's one file per contract. You can have them composable. You can upgrade them. And it's a system which is meant to be like trustless, independent. It's not controlled. It's not something from chain security, right? We present a new standard here, which can be used to achieve that. We give a reference implementation, but all of that is open and free to use. So I'll give you a quick motivations like for these kind of files from the different perspectives. So you are a project and you did write your code, you got it audited or not, but now it's time to deploy or it's time to upgrade, right? Depending on your use case. But did it go correct? Like, did the deployment work as expected? You can have transaction reordering, you can have reverts in there. Some people some bots, right, might have seen something, try to front run your initialization. Are you now really the owner or not? Are all the contracts you used, which you set up, the correct ones, right? And is it what you tested? Is that also what happened on chain, right? You might do the thing which we always suggest people to do, like do fork mainnet tests, but also they depend on some historic state, right? They seem to work. Now you deploy, you want to make sure it's the same thing which I used to assume the case is. From the auditor perspective, why stop at just auditing the code, right? So you did audit the code. You do understand that system, but deployment often is out of scope. So now you can check it, right? You can say constructor parameters, are they what they should be, but also are the follow-on config changes done in separate transactions, are they what they should be? And as an auditor, something which I also struggled with when creating that presentation is like you do have an implicit or explicit trust model in your head, like assuming certain roles behave in a certain way. But often that's not documented. Very few audit reports do say what the trust model is. And then for users, it's hard to say, is it like safe to use, right? So all of this is from the auditor perspective. Now, a simple perspective from the user, like really you just want to use safe smart contracts, right? So how do you figure out, has this code been audited? How do you check if the deployment is still secure? Did they do some upgrades or not? Did configuration changes break the project, right? I mean, all of that happened. A very practical use case. Some of you might be delegates. Some of you might be in charge of having to sign off on an upgrade. And I myself am, and that is too much work in that sense that you think it should be easy to check, but it's not, right? It's really hard to figure out, is that upgrade what they really wanted to do? Did they set all the correct parameters? Very tedious work currently. So who audited it and who checked those values independently? Why does everyone have to do the same work over and over again? Lastly, integrators perspective. This is another project. Like many people want to integrate with Uniswap, with Aave, with all the big projects, right? And then you always need to make sure, are you integrating with a version you are expecting? What trust assumptions did that version have? Is the code I'm looking at the code which is on chain? It can be pretty annoying, right? Some projects do a good work, but many, it's very tedious to figure this out. And lastly, some assumptions might change over time, right? So famously, you might read that in many audits reports, right? Fee on transfer breaks your project, but you say, well, I am not going to onboard any ERC20 which has fee on transfer. But then again, like USDT has it. Like they can activate it, right? Another thing which sometimes happens, like for Uniswap, LP fees. So the fees which like Uniswap would get directly through LPs, they are disabled, right? A big discussion. And what happens if they get activated? Like these assumptions for integrators, they are very important. So I'm going to introduce this. So we want to have that new format, which, if you come from the DevOps side of things, think of it as terraform, right? It's a file which describes the state, how it is supposed to be. It ensures, that's the starting point, what you have in your Git repo is what's on chain. Pretty simple, but it goes way beyond, right? So here, like it documents the expected state, the expected critical contract state. For example, proxies, right? The proxy should point to some implementation, right? And if it changes, you want to know. But there are many other variables, like it can detect if those things change, and it can also make sure they didn't change and change back, right? You can imagine this case, someone upgrades to a malicious implementation, does some state changes, updates back to one which you think is fine, and you will never notice, right? So it covers this by tracking the state diffs over time. And lastly, it allows you to reference other deployments. So you can say like, I'm dependent on that system and so on, and that system has a certain assumption about the behavior and so on. So you reference that in the files. But I'll just quickly show you, let's see how well this works, what this would look like. Okay, and just very quickly, general idea. Project deploys contract at some point, runs a lot of configuration transactions. Someone who creates that file would then go ahead and later create it based on a snapshot after the configuration has done. And then at any point in time later, right, usually much later, a user would validate, is that file still valid? Is that deployment still what's expected to be? Okay, so just to show you some stuff. How does it look like? I picked kind of a random project we are not associated with, and in this case, that's eigenlayer, right? So all you need to do, you need to say like this contract is at this address, and then version, chain ID. But that's very simple, right? That's all you need to do. Then you start. You see the command line here, right? So you say like, hey, my code is at eigenlayer contracts. This is a proxy you saw before, like I was saying, like it's a transparent upgraded proxy, right? So we tell it where's the implementation. In this case, it's an implementation strategy manager. This is needed to resolve storage variables. And then you just reference that file. In this case, I'm also giving the initial block. And this is because by default, if you don't provide it, it will take the block right after the contract has been created. But in this case, a lot of config settings were set in future blocks. So that we see what happens there. I have that. So I might switch to my laptop because you did not see what was supposed to come here. Is that possible? No? Okay. Okay, that's a little bit hard. So you, Is there someone who can support this? Like what? Just keep going? Okay. So you'd see some output here, which is not visible, and it would tell you like the bytecode has been verified, and it would decode state variables. Let's see. So I assume this also doesn't work. Like this is a longer video on how the thing works, right? So that's unfortunate. The presentation will be online, so you can check there, and then all of that will be available. So I'll just try to briefly explain some important parts in there. Most importantly, so it generates a JSON file which describes the critical storage slots. It decodes them in a way so it's clear for you what you are actually doing, like it's balances and not some random hash and so on. It tells you where these things are, right? And then you can edit that file. It dumps the full state, but for us it's important to define the critical state. So basically your job as someone who creates those files is to delete a lot of stuff out of them where you say like, look, that's not a critical state, it's supposed to change. It will dump all the events which happened, and then you'll delete everything which you say it's not important to stay the same. But some critical events like upgraded and so on, you would want to keep it. So now the big thing is like how does it all work, right? And most importantly, because we are in blockchain, who do you need to trust to make this thing work? So the idea is no one, right? So anyone can create that. There is an on-chain registry where you can say, I am someone who creates these DVF files. You can register there, but in the end, the user is empowered to say where they want to pull it from. The DVF files can be signed, right? You can sign them with Ledger or with private keys or whatever. And users would generally say, look, I trust certain, perhaps auditors, certain providers to give me good information, to delegate trust to them to some degree, but also you make it very easy to inspect what did they actually sign off on. So some hard things we faced while doing that. Obviously, how do you make it pretty smooth to decode those values? You can, like a slot, Ethereum storage slot looks like that, right? So that's a mapping in this case, and you need to tell someone what it really is, right? In this case, balance is the owner, and the value is not 246D hash whatever, but it's 42 times 10 to the power of 18, a lot more easy to understand. If someone put in state you didn't expect, it will not be able to decode it. It will warn you about it, so you can say like, hey, what has been going on here? We have versioning included, so because contracts do upgrade over time, right, and so on. So you can do all of these things. What works already is if you have a Foundry project, and like a big shout out to EtherRS and the things, all of that is built on top of that system, then you can run it already. All right. Then we can validate them. We can do upgrades, create new files based on new state. They can already be decentralized distributed and fetched and so on. All of that is working. You can sign them with, so far, either you have a private key on your disk, right, or you do have a letter to sign off. So all of that is working. As a quick summary, take-home message in this case, like deployment validation enables like projects to show that their project has been deployed correctly, both to them and to others. Auditors can document what deployment states are safe. Users now have a very easy way to check if that code has been audited, if it is still what they intend. Like DAO voters have it much easier to see like what I'm actually signing off on was the intended changes. And lastly, integrators, and then obviously we, like builders, this is very important, they can really ensure that they are interacting with the right system, make that much easier. And also they get the trust assumptions around this. Then they're very, like, you would have seen it before, but they're very easy to generate, right? And then very understandable, like much easier than anything which I have seen before, where you had to go to multiple websites to do this kind of things. And my message here, of course, you should start using them. Now, using them is currently something which we want to enable the first people to do it. Like we never brought this out, so we want to get feedback. Please If you are interested to try this, to use that, go to GitHub/chain security/deployment validation and say you're interested. Before we make it public, like open source, we want to get some initial feedback from everyone to fine-tune it, to incorporate that feedback. And we have an idea of future features, there should be an EIP which describes that file format. There should be like perhaps hard hat support to support older projects and so on, right? Or ones which use hard hat today. Many of these ideas, very welcome for input from your end, what you would need for this kind of stuff, and then obviously collaborate. Like this will be an open source project. So. You want to show the demo? We're going to have it where you can show the demo. Ah, okay. The video? Nice. I know I'm out of time with the speaking time here, but... You want to show it? Yeah, sure. Go back to that. Oh. Okay, yeah, I think that's it. Yeah, so you see this file which was created, like contract name, right, where it's at, the code hash which has been deployed, these are the important parts, and now the list of the critical storage variables. Like, it has been initialized. Initially, I was very confused when I did it for the first time because it wasn't initialized. You see the owner, you will check, is that the intended owner? You have some other variables, like for example, the status here. You might say like, okay, status is not a critical one, right? You get rid of it, you delete it. Then we check all the others, implementation and so on, generally very critical storage slots. We go down and see that there are critical events, like the admin has been changed, right? What happened here? You'll want to reason about what happened here. The beacon upgraded. It did never happen, but you want to document that it never happened, like, because when it would change, you would want to make that this file becomes invalid. And here you do see that actually this contract has been upgraded twice, right? And actually it first was upgraded to empty contract and later to the implementation contract. So these kind of things you can very easily see here. We still work a little bit on like making it even easier to decode. And then in the end, you can also say a little bit like who you are. You can sign off on this. You can describe what you are seeing. And the idea is this file will live in the project repo. So people have it very easy to say like, hey, this is where things are deployed. This is what it describes. But it will also live inside auditors, like auditors or other trust providers will give this out and then give their idea of what they think the system is safe. And then you can compare. Right? So yeah, this is how the file currently looks like. Thanks for making this possible.
Give it up for Matthias. Thank you very much.